welcome to this episode. Today we are going to take integration, still under calculus. Okay, I want to stay tuned for more because integration is actually deep. We are going to take more into this. Okay, so integration. Let's get to know the concept and the idea behind this. This is actually the sign for integration, and it's also called the antiderivative. Some people also say the antiderivative, whichever your language demands you to pronounce it. Okay, so let's say we have ax to the power n. If you want to integrate a function, let's say this, you have ax to the power n plus 1 all over n plus 1 plus c. It is not difficult. This is just a general integration. Ax n plus 1. This is the powers of x. You are going to add 1 to the powers of x and divide the term with whatever you get as the sum of the algebra that you've done here. You divide the whole term with it. Alright, so let's see. Now in this we'd have to add the x. So let me rewrite it. Ax n dx, which is giving us ax n plus 1 all over n plus 1 plus c. Okay, why are we adding the x? The x is there because the function is in terms of x. Just as how we write d dx, dy dx, where we know that the function is in terms of x. Let's say d dy, let me give a function of, let's say, okay, let me take this one. F of x is equal to 3x squared plus 4x. Now if you want to find the f prime, what do? The f dx, and the x over here is determining that the function is in terms of x. That is how come we have to put the dx over there. Alright, so this is it. Let's take a typical example. Let's say integrate a simple function like 4x cubed plus 6x plus 2 dx. If you're asked to integrate this, what do? This is the operational signs between them is plus. So what do? You have the term, integrating it each a term by term. So we have it that this will give us 4x3 plus 1 all over 3 plus 1 plus 6x 1 plus 1 all over 1 plus 1 plus 2. Now you know that the x over here is to the power 0. 0 plus 1 all over 0 plus 1. Alright, plus some constant c. What now do we have? You have 4x to the power 3 plus 1, 4 all on 4 plus 6x plus 6x to the power 1 plus 1, which is 6x2 squared all on 2 plus 2x to the power 1, which is 2x plus our constant c. Okay, so what do you have? We know that this will take away this and this will cancel this, leaving us 3. So what will be our final answer? You have 4 plus 3x squared plus 2x plus c. Let me put my plus row plus c, which is a constant. So the integral of this function is this. So that will be the final answer. Let's see. We have let's take a function like f of x to be equal to 3x squared plus 4x plus 13. Another function to be like f of x, no, let me give this one, g of x to be equal to 6x squared plus 4x plus 12. Okay, let's find the f prime of this function. F prime of x is going to give us what? 6x plus 4, right? Now integration is like you have your function f of x. Okay, when you differentiate it, it changes. When you integrate it, you get back your function. Okay, so let's see. That's why the integration is called the antiderivative. So this is it, the f prime of x. Now this f prime of x, we want to still integrate it to get back our f of x. In doing that, let's integrate this and see. So the integral of 6x plus 4. When you integrate this part, what will you have? Sorry, this is the x. Well, what are you going to have? You are going to have 6x 1 plus 1 all on 1 plus 1 plus 4. Now you know the x over here is to the power 0. So 0 plus 1 all on 0 plus 1 plus your constant c. Sorry, 0 plus 1. So what are we having? We are going to have 6x squared all on 2 plus 4x plus c. This takes away this, giving us 3x squared plus 4x plus c. Now you realize that we've now gotten back our function f of x. 3x squared plus 4x plus 4x. Now the 13, this is why we now bring the c. It's a constant, even that there could be another constant. Okay, that is why we bring the c. So it means that the c now is equal to 13. So if you are being asked to find what is c in relating to this, our c is 13. Okay, let's do the same thing to g of x. So what will the g of x give us? What will the g of x give us? Our g of x is what? G of x is 6x squared plus 4x plus 12. Finding the f prime of g prime of it will give us 12x plus 4. Right? Now let's integrate this back. So the integral of 12x plus 4 is going to give us, this is going to be what? 12x squared all over 2 plus 4x. Right? This takes away this, giving us 6. So what are we going to have? 6x squared plus 4x plus c. You see that we've still gotten back our function, the g of x. The 6x squared plus 4x plus 4x. Now our constant c is representing 12. Alright, so let's still take example 2. Example 2. Let's say integrate 2x squared plus 4x minus 6 dx. Okay, so integrate that simple function. Now we have it that is going to give us 2x to the power 2 plus 1 all over 2 plus 1 plus 4x 1 plus 1 all over 1 plus 1 minus 6x to the power 0 plus 1 all over 0 plus 1 plus our constant c. Alright, so what do we have? Is going to be 2x to the power 3 all over 3 plus 4x squared all on 2. Sorry, this is minus 1, so it's going to be 6x plus some constant c. Okay, notice these that we've integrated to get this, since the operational signs are plus and minus, it's still the same as doing it as the integral of 2x squared plus the integral of 4x minus the integral of 6 or dx. You can choose to still write it this way, or you can still put it as integral of 2x squared dx plus the integral of 4x dx minus the integral of 6 still dx. Alright, so it means that it's just the integral of each of the term. It can still be written this way, or it can still be written this way. All the same, When you integrate this, you still arrive at the same answer. Alright, watch out for more. I shall update you on more questions, how the lecturers or professors, examiners trick you whenever it comes to integration. Be ready for more.